Welcome to Resilient Software, Engineering the Future. In this episode, we explore 150 groundbreaking research papers from June 2025, focusing on software engineering breakthroughs. Our journey spotlights artificial intelligence, automation, and the human factors driving digital reliability. Get ready for an in-depth look at the themes shaping the next era of software, right here on AI Frontiers. This presentation will guide listeners through the latest advancements in software engineering research. The discussion will highlight how artificial intelligence and automation are fundamentally transforming the field, while also examining the critical roles of human and organizational factors. 3 seminal papers that are driving current breakthroughs will be spotlighted, and key future trends and ongoing challenges in software engineering will be previewed. This comprehensive overview aims to provide a clear map of the software frontier. Software engineering is the systematic discipline dedicated to designing, building, testing, and maintaining software systems. It underpins essential services in banking, healthcare, transportation, and nearly every aspect of daily life. Emphasizing teamwork, structured processes, and repeatable methodologies, software engineering contrasts sharply with the notion of solitary coding. Its high stakes are evident. Software failures can have global consequences, from financial losses to threats to human safety. Ongoing research in this field is driven by the goal of creating safer, smarter, and increasingly reliable systems for the digital age. Artificial intelligence, particularly large language models or LLMs, is now a core collaborator in software engineering. These advanced AI systems automate code generation, unit testing, and bug fixing. For example, SemAgent, developed by Paba and colleagues, leverages deep semantics for enhanced program repair. LLMs are also rigorously evaluated for their ability to generate unit tests, as shown in research by Saeed and others. AI agents today are capable of understanding not just code syntax, but also its context and intent. Large language models represent AI trained on both code and natural language, serving as powerful assistants for developers throughout the software development lifecycle. Automation and benchmarking are leading to smarter tools and safer code. Automated tools now streamline testing and verification processes, as demonstrated in the work of Kang and Associates. Benchmarks such as Front-End Bench, developed by Jean and colleagues, are raising standards for reproducibility across the field. Fuzzing benchmarks like those documented by Chen et al. Enhance the security and reliability of software by systematically generating inputs to uncover hidden bugs. Formal methods, which provide mathematical assurances of correctness, remain essential for safety-critical systems. Fuzzing in particular refers to the automated generation of inputs to expose vulnerabilities and ensure robust code quality. Human factors and socio-technical dynamics are now recognized as central to software engineering success. Research by DeSorbo and collaborators shows that patterns of team communication can predict the accumulation of technical debt. The concept of community smell serves as a metaphor for social warning signs that indicate potential software issues. Human practices, including collaboration, communication, and organizational culture, are found to be as influential as code quality itself. Studies increasingly highlight the importance of diverse collaborative teams, underscoring how organizational factors fundamentally shape software outcomes. Emerging paradigms, including quantum computing and multimodal systems, are introducing new challenges and opportunities for software engineering. Quantum software testing, as explored by Huang and colleagues, requires novel methodologies. Large language models are now being applied to refactor quantum code, as demonstrated by Ma et al. Multimodal systems, which blend code, visual information, and language, are gaining prominence. The rapid evolution of computing models demands swift adaptation from researchers and practitioners alike. Ensuring reproducibility and establishing robust evaluation standards are essential as these new paradigms take hold. Key findings in modern software engineering indicate a major transformation underway. Large language models are revolutionizing automated program repair and code testing, as demonstrated by Paba and colleagues. Context-aware tools are consistently outperforming generic one-size-fits-all approaches. Safety and explainability remain critical for the successful deployment of AI-powered agents, as highlighted by Yao et al. Human factors, including communication patterns, are now reliable predictors of software quality. Rigorous benchmarks, such as those introduced by Lee and team, are exposing both the strengths and limitations of current tools, guiding the next steps in research and practice. Modern software engineering advances through several core methodologies. Empirical benchmarking using large and diverse datasets enables objective evaluation and comparison of tools. AI-driven code repair and generation are streamlining development workflows, automating tasks that were previously labor-intensive. Formal methods provide mathematical guarantees of software safety and correctness, particularly for critical systems. User studies offer insights into real-world team dynamics and the challenges developers face. Hybrid approaches, which combine symbolic techniques with neural reasoning, are emerging as powerful strategies for tackling complex, multifaceted problems. SemAgent, a semantics-aware program repair agent developed by Anvith Pabba and co-authors in 2025, addresses the limitations of shallow bug fixes in automated program repair. By integrating issue semantics, code semantics, and execution semantics, SemAgent enhances its understanding of bugs beyond surface-level symptoms. This agent achieved a 44.66% solve rate on the SWebBench Lite benchmark, outperforming peer workflow-based approaches. Notably, SemAgent excels at repairing multi-line and multi-file bugs, a significant advancement over more localized methods. The paper was selected for its substantial impact on the development of robust context-rich program repair solutions. Humanity's Last Code Exam, or HLCE, introduced by Shunyun Lee and colleagues in 2025, establishes a new benchmark using 235 of the most challenging problems from the International Collegiate Programming Contests and the International Olympiad in Informatics. This benchmark evaluates whether advanced large language models can tackle the hardest code challenges solved by humans. The top-performing LLMs achieved only a 15.9% pass-at-1 rate, underscoring significant gaps in deep reasoning and planning. These models also struggled with accurate self-assessment. HLCE raises the bar for code generation evaluation and highlights key areas where AI still lags behind expert human programmers. A recent study by Ihor Peznani and collaborators in 2025 assesses the practical integration of AI-driven tools in quality assurance for distributed software systems. Their implementation achieved an 8.3% flaky rate, indicating readiness for real-world deployment. However, the paper also highlights significant risks, such as the black box nature of AI agents and challenges in test coverage. These findings present a balanced view of AI's current and future role in software quality assurance, emphasizing both its potential and the need for robust verification frameworks and transparency. The future of software engineering is defined by the pursuit of trustworthy digital systems. Progress will depend on the development of deeper, more context-aware AI tools capable of robust reasoning about code, requirements, and team dynamics. Bridging technical, human, and ethical perspectives will be essential. New frameworks are needed to address the challenges posed by quantum and multimodal software systems. Strengthening standards for reproducibility and transparency will support more reliable research and development. Collaboration across research, development, and practice is expected to accelerate this evolution, fostering innovation on all fronts. This synthesis was created using GPT 4.1 by OpenAI for comprehensive research analysis. Text-to-speech narration is provided by Deepgram, and visuals are generated by OpenAI's image systems. All synthesized content and academic citations have undergone human expert review for accuracy. However, some oversights may remain, so please consult the referenced materials for complete verification. All research and findings discussed are drawn from the set of papers published in June 2025. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.